Alright, this video is about properties of the quadratic function when it's written in standard form. And we are going to identify, define, and graph quadratic functions, and we're also going to use maximums and minimums. So, previously we learned about vertex form, which is a times the quantity x minus h squared plus k. Now, another useful form is standard form, and standard form is ax squared plus bx plus c. So we can compare these by going from vertex form to standard form by multiplying out, distributing this x minus h squared. If we expand that, multiply it out, and distribute the a through here, we can get this comparison. So now I've taken vertex form and I've expanded it. I can compare that to standard form, and when we do several characteristics of the graph here can be noted by comparing it like this. So let's look at what those are. The first is that with the a here. Now the a remains the same. The same a that we had in vertex form is the same a that we have in standard form. And that a tells you whether or not it's a reflection or whether or not it's a vertical stretch or compression, just like it did before. So that's a. Now before we learned that the axis of symmetry was at the value h, x equals h. But now that it's in standard form, the axis of symmetry is at x equals negative b over 2a. So this is important, you're going to need to know that. The axis of symmetry is at negative b over 2a. And then the value of c actually gives us the y-intercept. So because c is what you would get if you were to plug in x equals 0 into the equation. This would be 0 and this would be 0, and the only thing you would have left is c. So c tells us the y-intercept. Okay, so here is a summation of what you need to know about standard form. For f of x equals ax squared plus bx plus c, where a, b, and c are real numbers, the parabola has these properties. The a value tells us if it opens up or opens down, depending on if it's positive or negative. The axis of symmetry is at negative b over 2a. We can find the vertex by plugging in the point from the axis of symmetry, and then the y-intercept is c. To find the vertex, plug in the value from the axis of symmetry. Okay, so let's look at an example of a quadratic and see if we can pull all these properties from the equation. Okay, so when a is positive, the parabola is happy. When a is negative, the parabola is sad. Okay, here's an example. Okay, so we have this function. Let's see, can we determine whether or not this graph is going to open upward or downward? Well, when I look at this, I see the 2. Because the 2 is positive, the graph is going to open upward. The value of a is positive, it's going to open up. So now can we find the axis of symmetry? Well, the axis of symmetry is at negative b over 2a. So I'm going to plug in negative b over 2a. So I have to figure out what b and a are. I look at my function and I see that the coefficients here tell me what a, b, and c are. The coefficient of x squared is 2, so 2 is a. The coefficient of the middle term here is negative 4, so negative 4 is going to be b, and 5 will be c. So when we plug in, we're going to have negative 4 over 2 times 2. Negative 4 over 2 times 2, which gives us positive 1. So that means that the axis of symmetry is at the line x equals 1. Now, to find the vertex, we can just plug in, since we got 1 for the symmetry, we can just plug in 1 into this function and see what we get for the vertex. So, what we can do is just plug in 1. So we're going to say the vertex lies on the axis of symmetry. So the x-coordinate is 1. The y-coordinate is the value of the function at this x value. So put in 1 for x, and when we plug in, we get 3. That means that the vertex is at 1, 3. Now the y-intercept is just the value that's on the end, the value of c. So since I have a 5 on the end, because c is 5, the intercept is 5. So we can use the things that we just said to graph the function. To graph it, first I'm going to put my axis of symmetry right along the place where I found it, where it was. It was at x equals 5. So at x equals 5, we're going to draw a red. We got 1 for our axis of symmetry, didn't we? So at 1, we're going to put a reflection line at 1. And then we found where the vertex was. We found the vertex to be at 1, 3. Okay, so that would be here, 1, 3, we put a dot. And then we found that it crosses the y-axis at 5. So coming to 5, we would put a dot at 5, and then we can just make it symmetrical on the other side of the parabola, on the other side of the red line. This point 5 would reflect to the point 2, 5. So then you can just draw the u through the points that we have. Okay, another example. Does this parabola open upward or downward? Well, because we have a negative in front of the x squared, like a -1, this graph is going to open downward. The axis of symmetry is going to be at -b over 2a. So we need to substitute those values into -b over 2a. Looks like my a is going to be -1. I'm just looking at the coefficients here. The b is going to be -2. And c is +3. So when I substitute into -b over 2a, I get the value -1. So -1 is where my axis of symmetry is. And if I plug -1 into the equation, I can find the vertex. So when I plug in -1, I'm going to get -1 squared minus 2 times -1 plus 3. I get 4. So the vertex is at -1, 4. Now the y-intercept is just what the value of c on the end, so since we have a 3 on the end here, the y-intercept is going to be at 3. We could also find the zeros of the function by factoring it. If we were to factor this, we would factor it into negative x plus 1 and x plus 3. Okay, and if we put each of those equal to 0, we would solve and get x equals 1 and x equals -3. So we can use that to graph this. Okay, so first I put my axis of symmetry. We got that to be at -1. I know that my zeros, you can put a dot at x equals 1 and a dot at x equals -3. And then we also already found the vertex, which was at -1, 4. So connecting those 3 points, we can draw our parabola. Now about maximums and minimums. When a parabola opens upward, okay, if it's opening upward, then it's going to have a maximum. Okay, and if the parabola is opening downward, wait a second. If the parabola is opening upward, then it has a minimum. And if it's opening downward, then it has a maximum. The domain for all these parabolas is all real numbers. Now the range will depend on what y values is covered. See, it's only covering here. It starts at this value of k, and it's only covering these top values over here. So it doesn't cover the entire y-axis. But the domain is always going to be all real numbers for parabolas. Substituting any real value of x into a quadratic equation results in a real number. Therefore, the domain of any quadratic function is all real numbers. The range of a quadratic function depends on the vertex and the direction that the parabola opens. Okay, let's see if we can find the minimum and the maximum of this. First of all, since the value of a here is negative, okay, that means that the parabola is going to be facing down. Since it faces down, it's going to have a maximum value. To find that value, we're going to use -b over 2a to substitute in to find the x-coordinate of the vertex. So we're going to substitute in. It looks like our a is -3, b is +2, c is -4. So plug in -b over 2a, and we get our x value here to be 1/3. Now if we plug 1/3 into the function, we can get our y value. We plug 1/3 in, and we get, in this particular case, -11 over 3. That means that the vertex The maximum value is negative 11 over 3. The domain is all real numbers, and the range is all real numbers less than or equal to negative 11 over 3. Good. And I think that finding the maximum value there is the, okay, let's do another example. Let's see if we can graph this one. Okay, so if we graph it on our calculators, we can actually support our answer that we just got. And we are going to learn how to graph them too, and how to find the maximum and minimum directly from your calculator, as opposed to using the algebraic way that we were just talking about. So it can be done either way, and great. We will practice this in class tomorrow.